Hello, STEM Nation. Jeff here, and welcome to episode number 36 of STEM on Fire, where we interview practicing professionals in the area of science, technology, engineering, and math to help guide students interested in STEM careers. If you like what you hear, please share it with a friend. Now let's get fired up with our guest, Kenton, and I hope our chat will help ignite your passion towards a STEM career. Kenton Harris earned a Bachelor of Science Degree in Mechanical Engineering from the University of Virginia, and his career path has taken him down the manufacturing road. He has worked at Husco International as an advanced manufacturing engineer and currently works at Tesla as a senior manufacturing engineer. Welcome to the show, Kenton. Fill in any gaps and share a bit of your personal life.
Thanks, Jeff. Happy to be here. Yeah, I've had a windy road on my way to manufacturing, but I've experienced both mechanical design and product management, and then really have dug into manufacturing in the past few years. Personally, I'm a triathlete and was a really avid swimmer, and my wife and I are about to have our first baby. So very exciting times in our life.
Congratulations. Your life is going to change, and it'll change for the better.
Yeah, we're really excited.
All right. So, Kent, let's get fired up here and let's get right into it. So you do have a mechanical engineering degree, and most would think that you would stick with mechanical design, but you've evolved into manufacturing. Could you share with STEM Nation how this type of career path came about?
Sure, absolutely. I have a couple good stories of that. So when I was about 10 or 12 years old, I toured a nuclear submarine. My dad was in the Navy, and I saw the stuff on the sub and was just enthralled by it. And I thought it was just the coolest stuff, the torpedoes, the Tomahawk missiles, like all the little nooks and crannies that they stick things into. So I kind of came out of that and said, I want to design this stuff. And so that's what I first did. I went to work for a defense contractor and designed electronic equipment. I did mechanical packaging, so I had a very mechanical design oriented role. And I learned a lot about thermal loads and how to design equipment to handle those, and vibration loads as well. And then I got a call from a college friend that said, hey, we're working on a startup for the defense industry, and we're going to kind of rethink how defense industry is done. And I was like, oh, this is great. We're going to get rid of all this red tape. And so I went and worked for a startup that made a giant blimp for the Air Force. And so did that for a little while. And I was really excited about this mechanical design stuff. And we made the blimp, and then the Air Force canceled the program, and it was really disheartening experience for me. And I said, I want to work on something that's going to get made. So you can you have this idea on paper or on your computer, and you want to see it actually get manufactured. And that's kind of when I started working for Husco, making hydraulics for construction equipment and cars. And I really thought that it was important to, the really most rewarding part about engineering to me is to see that design come to life, and to see it on the road every day, or to see a car, or see a excavator you drive by and say, oh yeah, the valve I work on was in that. It's a really cool experience to see. I think that's one of the best parts about engineering, is getting that satisfaction of your idea coming to life. So yeah, and now I do manufacturing for Tesla and work on their cars, and really focused on how you can make a product once, but how do you make it again and again and again, and maintain that high level of quality that everyone expects.
Yeah, going from designing a blimp and making maybe a couple of blimps to manufacturing automobiles, that's completely different. And I guess, yeah, you have to be able to manufacture that and repeat that very precisely over and over and over again.
Exactly. Yeah. It's a totally different set of challenges where, if you're just making one thing, you can take as long as you need, or maybe not as long as you need, but, you have a lot of resources available to you to make a one-off perfect, and you can make it incredible. It's another thing to make one every 60 seconds for the rest of time.
So how do you think mechanical engineering compared to, let's say, an industrial engineer? I think of industrial engineers going more into the manufacturing side. How did your mechanical engineering degree provide advantages in the environment or in the manufacturing world?
So I think a big way is it provides you, they call it a DFM, which is Design for Manufacturability. And by having a design background, it allows you to provide feedback to the other design engineers of what types of design work the best for manufacturing, what might be an easiest thing to manufacture. So for instance, as a design engineer, I want to use a bunch of screws to screw the part together. But if the part's never going to come apart again, it's often easier to use like a snap hook or a one-time feature that's going to hold it in place, because then you don't have to have a screwdriver. You don't have to have the screw itself. You don't have to pick it up. So you can just push the part into place. So there's those kinds of considerations that someone with a manufacturing role but a design background would be able to tell the design engineers of, why are you using 20 screws? You only need 3 snap hooks. That type of thing. I think that is a lot more valuable. I think from an industrial engineer, I tend to think of them more laying out the floor space in your factory, and I'm kind of more closer to the product. So kind of in between the design engineer and the industrial engineer.
Okay. So do you get involved a lot early on in the design of the equipment so to make sure that it is manufacturable?
Absolutely. Manufacturing engineer is in charge of all the tooling. So what does the tooling that holds the part look like? And then how do you perform the process on the part to change it? And, if you're going to drill holes in it or that kind of stuff, how are you going to fixture it and hold that? So while you're not designing the part that goes on to the customer, you're designing all the pieces that touch it on its way through the factory.
So, Kent, let's get specific here. And what is your area of expertise?
The number one thing I would say I do is help spec out a process. So, when you see this product, you have to determine, what is the process that creates that product. So you create a process flow, and then you determine what are my inputs from the supplier, what are my outputs out of the line. And most importantly, how do we test the product to make sure that it performs as well as it should? Specifically, you're setting limits as to, okay, I'm going to, nominally it's going to be 5, but plus or minus 1, and I will test that and I will check, is the thickness of this part over 7? Okay, well, that's going to be a failure. It can't work, but setting it up, maybe it needs to be plus or minus 0.5 and kind of dialing those numbers in and using statistics to figure out what is a good part and what is a bad part is a really difficult thing to kind of do. And I do a lot of it.
So, Kenton, what does a work week look like for you?
So my work week changes a lot depending on what phase of the project we're in. I think at the beginning of a project, you're doing a lot of theoretical designs and meetings trying to figure out, what is the best way to make this product. And then you transition that into, okay, let's make a few products and prototype them. So then you can go down and make a couple of them, right? The first thing you want to do is get your hands on the parts, figure out how they go together. Where are the pinch points? Where are the difficult portions that you're going to run into trouble? And then I spend a lot of time in CAD and design tooling that are going to hold the parts. And then I spend a lot of time doing layouts of, what if we do this process first? Or what if we do 3 assembly processes at once and then 1 test process versus assembly test, assembly test, assembly test, and kind of balancing those out. And then you basically send all those parts out for order or for manufacture, all your tooling, and then they arrive and you have to assemble them together. You have to make sure that they work as intended. And, you spend a lot of time on the factory floor right at the beginning, right? And that's, you kind of run off the machine. And then after that, you kind of look at the data and make adjustments. And then you move on to the next project. So my weeks change very often. I have times that are very high intensity, high stress, long hours. And I have times that are less stressful at the beginning and the end of the project where you have time to try new things or do some lessons learned from the completed projects.
And Kenton, if you had to pick one thing that really has you fired up in the manufacturing or mechanical arena, what would that be?
I'm huge into robots and automation. And I think that I foresee the 21st century as a time when there will be much more automated robots, either assisting people or doing more processes that didn't used to be able to be done with automated assembly tools. So I really love some of the kind of lower cost robots that get put in where you didn't used to be able to do it.
So, Ken, one thing I want to bring up is, some folks out there think, well, manufacturing is dead in the U.S. Everything is being manufactured overseas in low-cost countries. What's your insights into that?
There is, that still happens, but I think it is getting fewer and further between. I think that the ingenuity of American engineers will eventually bring some of those jobs back. I think we are continuing to find ways to automate things cheaper. And I think that if you look at the economics of, do we send this part, all the way to Mexico or to China to get made, and then bring it back, when you could make an automated line, downstairs and be there, and it can make as many or as few parts as you want, and then you can make something new on them, and reuse those pieces of equipment. I think that's really going to be the thing that brings the manufacturing back to the U.S. is finding a way to automate it.
Yeah, I think automated and these positions in the production world are going to be very highly talented positions that are needed, like STEM careers. I think the days of all the manual assembly, those are the bygone days.
Yeah, I mean, and there's still a place for it. I think we do a kind of person versus robot trade-off, and the more that I do, the more gets put into a robot, because the robot will do exactly what it's supposed to do every time. They don't get tired. They don't forget something. And so that allows a much higher quality product as well. And so a lot of times we determine that, is it manual or is it automated by quality more so than cost, because that can have a huge impact on overall lifetime cost of the product.
All right, thanks for that, Kenton. And if you could take us to an aha moment you've had, something in your work or your personal life, and tell us the story and how you turn that aha moment into success.
I love this. I've had 3 aha moments in my life, and I remember exactly where I was for every single one of them. The first one was my parents got cable internet instead of dial-up. Do you remember the first time you had cable internet?
I remember dial-up. I'm old enough. I remember not having dial-up. So yes.
Yeah, even before then. Yeah. So I remember dial-up, and then it was great. And then cable came, and all of a sudden you could get, data as fast as you could. I thought it was just incredible, and it was going to really change everything. And I really that was a huge aha for me of oh, this is going to be fast. I want to, be involved in this. And then the second one is my friend got an iPod, one of the first iPods. The wheel actually moved, and the rest of us were walking around with CDs and a giant book of them. And the first time I held this thing, I was like, this is really going to be incredible. And I wish I would have told my dad at the time to put my college fund in Apple stock, because it was really low right then. And I just knew, I was like, oh man, this iPod is going to be really cool. And even more so than when I held the iPhone, it was just oh, this is just the iPod again. But seeing that product for the first time, I was like, how did they put this together? And I immediately took it apart. As soon as I got one, this is brand new, really expensive thing, and I immediately took it apart because I wanted to see how it worked, and I was shocked that there was a hard drive inside from a laptop. And then, so my third one, and the most important one, I think, is it was the first time I ever drove a Tesla with autopilot. And so a friend of a friend had one, and we got in, and we went on the road, and you're just telling me, you just click this, cruise control stalk, just like cruise control, and all of a sudden the car was driving itself down the road. And I was just incredulous that this is finally happening. And there's two little blue lines on the screen that say, this car telling you basically this, I know where the sides of the road are, and I'm going to go right down the middle of it. And I saw it and I was like, I have to work on this. It's going to be, everyone is going to have this soon, and I want to be a part of it. And so I picked up my family and moved out to Nevada and started working for Tesla. But it was such an incredible, like, light years ahead of everything, but also knowing that soon everything else is going to be like it. It was like peering into the future.
And STEM Nation, if you want to experience the same things Kenton's doing, you have to get through these challenging STEM careers. So Kenton, if you could go back to when you're 18 heading off to college, what are some things that you wish you knew back then that would help our STEMers launch into college successfully?
My biggest one is hard work beats talent when talent doesn't work hard. I had a coach or somebody that told me that once, and nothing is as hard as you think it might be when you start. When you first are diving into a subject, you're like, I don't think I'll ever understand this. And I think people are afraid to try and fail. And so I think one of the biggest things is find a way to make something hard apply to you. Fluid mechanics, I was just terrible at. And I took this class in fluids, and it was a really tough class for me. And then they had a project where you basically made your own homework question. And I was a swimmer, and I had this parachute that the coach would put on. You put it on like a belt, and then you would swim with this it was a very small parachute, but it was a parachute behind you. And so my homework assignment I created was calculate the drag of the parachute going through the water fluid. And so I kind of made this analogy to this thing that I had experienced myself. And all of a sudden I was picking up this is why this equation matters, because this is how I use in the real world to figure out this drag force. So that making something apply to you and not being afraid to like try harder than you think, you're smarter than you think you are. And every super smart person I've met really was just someone that was willing to work a little bit harder than everyone else was.
Kenton, could you repeat that phrase that you had mentioned?
Hard work beats talent when talent doesn't work hard.
I love it. And we're going to take a quick pause here and thank our sponsor, Audible, who's offering a free audiobook. You could head over to STEMOnFireBook.com. That's STEMOnFireBook.com to get a free audiobook of your choosing. If you decide to cancel within 30 days, there's no cost, and you keep the audiobook. And we are heading to the lightning round. Kenton, are you ready?
I'm super ready. Let's light it up.
What's the best piece of advice you've ever received?
I have 11 words that are taped above my wall that keep me focused. And it says, one thing at a time, most important thing first, start now. Don't delay. Whatever the most important thing is, do it right now. Don't wait for anything else. Just get that one thing done that's the most important, and everything else will follow it. Deciding what the most important thing is becomes the hard part. But I always have this most important project, and they're like, I'll do that one tomorrow. I'll do all these easy ones first. No, don't do that. One thing at a time. Most important thing first. Start now. And
what's a personal habit that contributes to your success?
I'd have to say my curiosity. I really resonate with MacGyver. I don't know if.
Oh yeah, I know MacGyver.
You know some MacGyver things. So don't be afraid to break something and figure out a different way to use it. You can usually find a way to put it back together if you do it correctly. There's a couple awesome websites like iFixit that kind of show you how to take something apart. So I think everyone out there has a phone that has a battery that probably doesn't work as well as it should. Go replace your battery. Maybe in your old phone, not your current one, but they have these great teardowns, and that's something that I really think is a habit of always take something apart. You're always learning how someone else has designed something and why they made the decisions they made.
And did you get your iPod back together?
Yeah, maybe not the first one. But I definitely, I ended up repairing all my friends' iPods is what happened. I would charge them, $20 and I'd take their iPod apart and put it back together for them. So you can make it an enterprise.
All right. And what's your favorite internet resource or phone app and why?
Have you heard of Adafruit?
I've heard of Adafruit, yes.
Adafruit is the best. I love Adafruit. So Adafruit is a website that was made by an engineer. She went to MIT and makes kits for you to put together all of your electronics. And the best part about the kits is that they include the code for how the kit is to work. And I'm not a great coder, but I think that Adafruit does an incredible job of showing you example code. And I do what's called spaghetti coding, where you take little bits and pieces from lots of different codes and just kind of like copy and paste them together and then get it to do the thing you want it to do. So you don't really have to write anything from scratch. You can just kind of borrow the pieces you need. And the website has just incredible documentation, and it's got the coolest stuff in it. I used an accelerometer at work the other day my colleague bought this like $1,000 accelerometer, and I bought a $50 one from Adafruit. And mine, Adafruit has an app on their, like, you can download an app for Adafruit, and like their products work on the app. And I had this accelerometer traveling in the factory, streaming data to my iPhone as I walked next to it. And the guy with the $1,000 accelerometer had to plug his in to an SD card. So I outdid him very, very quickly. So I actually have a couple other ones. Can I put a bonus one in?
Absolutely. All
right. So on YouTube, How It's Made is this show that kind of walks you through. I think it was on the Science Channel back, a long time ago, but they put all the episodes up on YouTube, and it walks you through how everyday things are made. And so if you want to learn about what manufacturing is, go down the rabbit hole of How It's Made on YouTube. And it's incredible. It shows you how all sorts of stuff. I mean, I still find myself going to it on a regular basis.
And what's one book you would recommend, and why?
Favorite one lately is called Manufacturing Processes for Design Professionals. And it's almost like a coffee table book. It's big. It's by Rob Thompson. And it basically walks you through all of the different manufacturing processes that exist. And it's kind of an encyclopedia, but it's got great pictures and kind of like trade-offs for why you would use one process over another. And it's just gorgeous. Any engineer that sees it on your coffee table will just immediately start flipping through it. It's got incredible pictures in it.
Kenton, as we wrap up here, could you share a parting piece of guidance for STEM Nation, and then we will say goodbye?
Two things. Find a mentor and find a partner. So in a mentor, try to find someone who has done something cool, and then just say, hey, I want to pick your brain about this really cool thing that you did. And it doesn't have to be like, would you like to be my mentor? You can just, ask them about the project and pick their brain. And then the second thing is find a partner. And so find a lab partner, find someone that is interested in the same things you are, but maybe, compliments you in a way that you're bad. So, I'm very disorganized, and my college lab partner was incredible. She was very organized, and we complement each other really well. And one of the things I've been in a lot of different places. I try to make sure you maintain those connections with people that you've worked with, and tell them, I hope I get to work with you again. We work well together. We work on a team well together. So find a mentor and find a partner.
All right, Kenton, thanks for all that valuable insight and value. And with that, we will say goodbye.
All right. Thanks a lot, Jeff. I appreciate it.
You're welcome. I hope you enjoyed our discussion today with Kenton. Head on over to STEMonfire.com, subscribe to the email list to keep up with the latest happenings, and be sure to subscribe to the podcast on your favorite podcast player. We are approaching 10,000 downloads, and if you could share this podcast with one person, it'll help us reach 20,000 even quicker. Tune in next week, we talk with Kenneth, who is a civil engineer. Until next time, I hope this chat has helped ignite your